Hello everyone. Today I'm thrilled to introduce you all to a smart automatic lighting system. You all might have faced some problems when you're using lights in your rooms. For example, there are many people inside your family members or in your apartment or somewhere where they will turn on the lights and leave it as it is. They'll not turn off the light itself. This causes lot of wastage of energy and also wastage of the natural resources. So today we are going to overcome this problem by introducing our smart automatic lighting system. This lighting system, it not only automatically turns off the light on when the presence is detected and light off when the presence is not detected, but also it avoids manual intervention. So you don't need any person to turn off the light manually. See, it automatically turn off the light and turns on when presence is detected. So without wasting any time, let us start with our project. Smart automatic lighting system using an Arduino UNO board. So what we will cover today, we'll cover an introduction to automatic lighting system, why it is useful, what is a lighting system, what is automatic lighting system, and why it is useful in terms of automatic or making it smart. That we will learn today. Also, we'll learn some key components, understanding our hardware. What does our hardware comprises of? What are the key components that we used in order to achieve our goal for making lighting a smart or automatic system? How does it work? So what is the logic behind this system? And finally, we'll have a demo session where we will discuss 3 cases. First is using manual intervention, manual presence. So say if you put a motion sensor, put a hand in front of the sensor, then it will detect and it will turn on the light. The second case is we'll use a remote control, we'll press one key or any key and see that the light turns on and off. And the third case is, suppose you want to turn on the light for a particular key on the remote control, then how to do it? So all these 3 cases we are going to discuss in the demo session. And finally, we will discuss about applications of this automatic lighting system and how better we can improve this than the existing one. So without any further ado, let us start. Introduction to automatic lighting system. What is automatic lighting system? A system that automatically turns lights on and off based on environmental condition or presence detection. Suppose if a person enters a room without manually turning off any switch of the light, if he is able to turn on and off the light, that is called as automatic lighting system. He doesn't need to press any switch. Moment he goes out of the room, automatically light turns off. Moment he enters the room again, the light turns on again. So basically, the presence is detected inside the room and accordingly lights are turned on and off. So that is called as automatic lighting system. So what is the use of an automatic lighting system? Energy efficiency. It saves electricity by illuminating only when needed. We have been seeing the lights are turned on in the rooms generally where there are no persons at all. When there are no persons, then if the lights are turned on, it is complete wastage of energy and electricity. So with automatic lighting system, we can save electricity. Second is convenience. You don't need to turn on this light by pressing any manual switches. Just when the presence is detected, automatically the lights are turned on, and when the presence is not detected, automatically lights are turned off. Security feature. Suppose you let your house for 1 month without any residence. Say you go to some other place and you want to leave your house alone. So nobody is there in the house. But the burglars doesn't know. They think that you have gone. So to avoid such burglars or intruders getting into the house, what you need, if you turn on the light for all the time so that the burglars come to know that there are somebody inside the house, then they'll not dare to come inside your house. So that way, a security feature can also be taken into consideration by using automatic lighting system. Comfort. So provides light exactly when and where it is required. When you're there, the lights are turned on. When you're not there, lights are turned off with comfort. Okay. Now, before we get into the project exactly what are the components, we have to spend some time to understand what are these electromagnetic waves. Electromagnetic waves or electromagnetic radiation is a form of energy that travels through the space as waves having electric and magnetic fields. Why we are discussing about electromagnetic radiation or electromagnetic waves? Because in this project we are going to use IR remote control. The IR infrared is a part of electromagnetic spectrum and it transmits from one device to another device. It carries data from one device to another device in the electromagnetic wave format. It has got its own frequency of 38 kHz and a wavelength ranging from 750 nanometer up till 950 nanometers. So that is why we have to discuss some time about electromagnetic radiation. So electromagnetic radiation is a form of energy that travels through the space as waves having electric and magnetic fields. We all know that the right hand thumb rule that we have learnt back in our school days. The right hand thumb rule says that when the current is flowing in one direction, that is represented here in this picture in the form of thumb, the magnetic field is created exactly perpendicular in direction to the current. So whatever the red mark that you're seeing is the magnetic field here. So if this is the current flow, then the magnetic field is created parallel to it or perpendicular to it. So the force exerted will be in the other direction as represented here by the third finger or the middle finger force. So if the current is moving this direction, field will be perpendicular to it and the force exerted on the substance or on the entity will be in this direction. So this is the thumb rule. Now if I want to represent it in the three-dimensional direction, in the three-dimensional view, this is what is the picture. On the x-axis what you see, the blue color one is the current that has been traveling in this direction. On the y-axis or on the z-axis that you see is this electromagnetic field, red color. So it is perpendicular to this electric field. So that is how the electric field and the magnetic field are created. And where the force is executed? Force is executed in the third direction, that is y direction. So the entity moves in this direction having both electrical and magnetic properties. So that is how with this electromagnetic waves, it is able to travel in one direction exerting force. When we look at electromagnetic spectrum, where does our infrared stand? Where does our IR waves stand? If we see this electromagnetic spectrum here, it ranges from radio waves, microwaves, infrared waves, visible light, ultraviolet light, X-rays up till gamma rays. So this radio waves, as you see, it has got a low frequency and hence the wavelength is high. What is a wavelength? Wavelength is the distance between two crests and two troughs. So when the frequency is low, like for the radio waves, then frequency is low, the wavelength, the distance between two crests is high. Similarly for microwaves. And when it comes to infrared waves, slowly the frequency starts increasing. So slowly our wavelength starts decreasing. As you know, F is equal to V by lambda, or lambda is equal to V by F. So as and when the frequency starts increasing, inversely proportional to the wavelength. So if frequency starts increasing, the wavelength starts decreasing. If wavelength starts increasing, frequency starts decreasing. Then after the infrared spectrum, we have got this visible spectrum. Why am I saying this as a visible spectrum? Because till now, whatever the waves that you have seen, it may be radio waves, microwaves, infrared waves, these are not visible to your bare eyes because your eyes frequency is different than the frequency of these electromagnetic waves. So only after we cross the infrared magnetic band, it comes the visible spectrum here. The visible spectrum, we call it as visible because it is visible to your eyes, because it matches the frequency of your eyes with this spectrum. And it includes all the colors like violet, 𝐕𝐵𝐺𝐬𝐢, violet, indigo, blue, yellow, orange, all the 7 colors that it includes. Here is the picture, visible spectrum. So violet, blue, cyan, green, yellow, orange, red. So we'll start from red till violet because infrared starts from here till violet, because you see the wavelength starts decreasing from right to left. So as and when we move from right to left, red, orange, yellow, green, cyan, by the time you reach blue and violet, the wavelength starts decreasing and the frequency starts increasing. So you can see it here. I have clearly shown 625 nanometers, 740 nanometer, 590 nanometers to 625 nanometer, 545 nanometer till 590 nanometer, up till it has decreased to 380 nanometer to 440 nanometer. Then after this visible spectrum, it starts ultraviolet band, it starts X-ray band, and then finally gamma rays. So ultraviolet is emitted from the sun. You know, during solar eclipse time, ultraviolet rays are extremely radiated from the sun. So you should be very careful there because they are very harmful to your skin. And similarly, X-rays. X-rays are used to scan your body in the medical hospitals. So whenever you go, when you want to do a scanning of your elbows or internal organs, then X-rays are completely used. And finally, gamma rays. These are extremely dangerous rays because they are emitted out of nuclear reactors. So when the nuclear fusion or nuclear reaction takes place, then these gamma rays are emitted. Especially if there is any leakage in the nuclear reactors, these gamma rays emit and it will create havoc to the human beings. So this is about a brief description about electromagnetic spectrum, and we also got to know the infrared. Where does this where does this suit here? It is standing in this particular band. And what are other waves that are there, that also we got to know. Now with this introduction, let us move into our project. Let us come back to our project. So coming back to our project, what are the key components that we require for our smart automatic lighting system? First and foremost is Arduino UNO board. It is the most populous 8-bit AVR microcontroller board which has got around 14 number of pins which are digital or analog pins. It has got 32 kilobytes of flash memory. It has got 2 kilobytes of SRAM, and it has got 1 kilobytes of EEPROM. It clocks at a frequency of 16 megahertz and it can reach up till 20 megahertz also. So it has got a lot of features like UART, SPI, I2C, timers, various features it has got. So if you want more information about Arduino UNO board, please download the data sheet from the Arduino UNO website. Next component that we require is IR obstacle sensor. See, this IR obstacle sensor, it has two LEDs you see, but these are not LEDs actually. One is the IR LED transmitter and another is the IR LED receiver. This black one that you see is a receiver. It has got LM393 IC over here. So what does this LM393 IC do? LM393 IC is basically a comparator IC. What is a comparator IC? Probably we have to go back to our digital circuits which we learned in our engineering. We give two inputs at pin number 2 and pin number 3 for a comparator. So the comparator, what it will do, it will check both the voltages, and if the result is positive, then it will return high. If the result is negative, then it will return low. If we have to delve into it, let's get into depth of it. So the detector or the IR obstacle avoidance sensor module that we are discussing, it detects the presence of an object within its short range. How it works, it emits an IR beam and detects the reflections. So you can see here, as I discussed earlier, it has got two LEDs. One is the transmitter LED and another is the receiver LED. The transmitter LED, it transmits the light, and when there is an object presence, the IR light reflects back, and that reflected IR is being read by the other LED, which is called as photodiode, which is the receiver LED, black color one, and that is fed into the comparator chip, and that is again set the signal, the output signal is sent to the Arduino board. If there is no any object detected, then the IR light that is sent from the IR LED will not be reflected at all because there is no object. So when there is no any reflection from the IR light, so this photodiode will not detect anything, and that is given as input to the LM393 IC. LM393 IC, it further sends the logic high or low to the Arduino board saying there is no object detected. Here it is, I have clearly shown when V plus pin number 3 is greater than V minus, output is sent as low to the Arduino UNO board. When pin number 3 is less than V minus, that means when there is no object detected, then the output, the comparator LM393 will send is high signal to the Arduino UNO board. So this sensor acts as a motion or the presence detector. If you want more information about LM393, I would suggest you to download the datasheet for LM393 IC and study for yourself. Further moving, we also need other key component that is called as DC 5 volt relay. You can see here, it looks like this. It is a SPDT relay, that is single polar dual throw relay. It takes 5 volts as the input, 5 volts DC as the input. So why do we require relay actually? Because Arduino pins cannot directly power a typical light bulb. The relay acts as a safe intermediary because Arduino pins are all working on digital pins. They work on DC. So if you want to turn on the bulb which is running on AC, then you cannot directly use Arduino pins directly. So for that, you require relays. Relay, it will take the input as the DC and it will control the AC component. In our case, we have taken bulb as our AC component. So what does this relay contain? It contains 5 volts coil voltage and typically two types of contacts. One is normally open and the other one is normally closed contacts. So we can connect our bulb either to NO contact or NC contact. So when the Arduino signal is sent to this relay, the relay internally switches the state, connecting the bulb or disconnecting the bulb. So whenever the digital signal is sent from the Arduino to this relay, the relay internally, due to its magnetic coil effect inside it, it will change the state, connecting the bulb's power or disconnecting the bulb's power. So that way bulb gets turned on or off by Arduino digital signal. So if we look at our entire project block diagram, it looks like this. So we have this Arduino board here, UNO board, and to this we have connected IR obstacle avoidance sensor. So this sensor, it has got 3 pins. One is ground, another is VCC, another is VIN. Another component that we discussed is the relay. So relay has also got 3 pins. One is VCC, another is ground, and another is VIN. And the output of the relay, it is connected to the bulb. So as I told, we can connect bulb to either NO or NC. It is left to you. So this is the pictorial graphical representation of the project that we are going to do today. In detail, once I am showing you the demo, you will get clear-cut picture of exactly the pins that we have used for this project. So how this automatic lighting system works? What are the steps that it follows? Number 1, the IR sensor constantly monitors the presence. It constantly keeps detecting any object is there it will keep detecting. When an object is detected, the IR output goes low and the Arduino reads this signal. The IR output of what? The IR output of the IR obstacle sensor, it goes low. And when that low signal is read by our Arduino board, and based on its program, Arduino sends high signal to the relay. The relay then switches on, it completes the circuit of the light bulb, and hence you see the light bulb glowing, that is, it is turning on. Suppose the object is not detected, suppose the object moves away from the sensor, then our IR object or IR obstacle sensor, it gives the output high to the Arduino board. The Arduino board then reads this high output from the sensor and sends a low signal to the relay. Whenever the low signal is sent to the relay switches off, hence breaking the circuit. That means it removes the contact, it disconnects the light bulb circuit, and hence you see the light bulb turns off immediately. So this is the clear-cut working steps from how the sensor detects and how whenever the sensor does not detect, these are the steps that our system, automatic smart lighting system, follows. Now, let us directly delve into the demonstration without wasting any time. In this demo session, we will see 3 cases which I am going to discuss. Dear students, so we are seeing the demonstration of our smart automatic lighting system. Before we start towards the coding, I would like to show you the hardware setup of our automatic lighting system. This is our Arduino UNO board. This Arduino UNO board has got a microcontroller which is 𝐂𝐫𝐚𝐬𝐢𝐭𝐲. It is a 8-bit AVR microcontroller. It has got 16 MHz of clock frequency, and it can stretch up till 20 MHz clock frequency also. And you can see there are so many GPIO lines here. So this Arduino UNO board has got 13 GPIO pins, both digital and analog. And this supports pulse width modulation as well as UART support. It also has SPI. It has also got I2C support as well. Connected to this Arduino UNO board, we have our next key component, that is IR obstacle sensor board. As we discussed earlier, it has got 2 LEDs. One is the transmitter LED, another is the reception LED. And this chip that you see is LM393 IC. It is a comparator chip that we discussed. It will compare the reflected signal from the obstacle, calculates the voltage, and then sends it to the Arduino UNO board. This obstacle sensor has got VCC pin, ground pin, and output pin. It takes voltage from 3.3 volts up till 5 volts. So since it works on 3.3 volts also, I have given VCC to 3.3 volts VCC here, or from the Arduino board. Ground, we have to connect it to the common ground to the Arduino board. Next, the output pin from this IR sensor module will be sent to pin number 2 of the Arduino UNO board. So when I write my firmware, I'll be sensing the IR data at pin number 2 of the microcontroller on the Arduino board. So this is about the input part of the Arduino UNO board. Now let us come to the output part of the Arduino UNO board. Our next key component is the relay. The relay is a SPDT switch, as I've already discussed with you. It is a 5 volt relay. It's a 5 volt relay, 05 DC. It is clearly written. So it has got 2 parts. One is the input and here is the output. The input part has got 3 pins. One is VCC, another is ground, another is in pin. Since the relay takes 5 volts as the input, we have to give VCC to the 5 volts of the Arduino board. The other pin, ground pin, is given to the common ground of the Arduino board. The remaining third pin, the last pin, is given as input pin, which is being given at pin number 4 of the Arduino board. So this VIN is actually the command sent from the Arduino to control this relay that is being done at pin number 4 of the Arduino. Now coming to the other part of the relay, we are actually controlling a bulb, which is a AC bulb. It is not a DC or a LED. It is a AC bulb which takes a 240 volts AC, 50 Hertz frequency, and it is being connected to the power supply. Now I have break open this positive into two parts and given one part to NO and another part to the common. You can also give the other part to NC. In my case, I have just for my convenience, I have given one part to the COM pin of the relay, and the other part has been given to the NC part of the relay. So that way, whenever the command is sent from the Arduino board to the relay at VIN, the magnetic coil inside the relay get energized, and that is how it will switch the state from normally open to common. So when it is switching the state, the circuit gets closed circuit for the bulb, and that is how our bulb starts glowing. Right now it is in the open state, it is break open. Until I send the command, the bulb will not glow. Suppose I want to turn off, then I will send a low signal to VIN, and that is how our magnet inside this relay get de-energized and demagnetized. Then our state, which was common, it will come back to normally open on the relay side. When the relay comes back to normally open, then the bulb will, circuitry of the bulb will be break open. So your bulb will not glow. So if you want to glow again, you have to give a signal to relay, and then once the circuitry is closed, your bulb will glow once again. So this was about the hardware setup. Now quickly we'll get into our demo or the software part that I'm going to write. We'll discuss three situations here, three cases. One is when I put my hand in front of the sensor, the bulb should glow. That is case number one. Case number two is I have taken one remote control here. This is any TV remote control or AC remote control or any remote control, you take it. So I have taken one remote control. If I press any button on this remote control and transmit to the IR LED or transmit to the receiver LED, then our bulb should glow. If I press any key, that is our second case. Suppose on this remote control, if I have to press a particular key, only then I have to glow my bulb. So that case also we will discuss. So my bulb will glow only for a particular key of my choice. So friends, without wasting any time, let us see the demonstration of all three cases quickly. So students, let us see the case number one that we discussed. The case number that we discussed was when we put if we put a hand in front of the sensor, then the bulb should glow. Or when the motion sensor, when the object sensor detects any presence within inside the room, then the bulb should glow. This was our case number one. Let us directly go into the Arduino UNO source code that I have developed. See, this is the one. For initially, what we have to do is, we have to initialize the setup. We have to give pin number 4 for the relay, which is our output. Pin number 2 is for our sensor, which we have made it as input pin. Now, once this setup is done, we'll directly inside the loop, we'll give a logic. We have to write a logic saying, suppose if the digital read pin number 2 is logic high, then only we need to toggle the relay. So that is why I've written, if digital read of pin number 2 is equal to 1, then digital write pin number 4, high. Turn the LED on, high is the voltage level. Suppose if there is no signal detected in the IR object sensor, so in that case we have to write else digital write relay pin number is 4, make it as low. So your relay will turn off. If relay turns off, then that means your bulb also turns off. So let us see that demo quickly. So what we have done is, so this is our IR object sensor, which is being interfaced with Arduino UNO. Now the Arduino UNO board is connected to my laptop. Now the source code I will directly flash onto the Arduino UNO board. So let us do this. Yes. So it says done uploading. So that means my Arduino UNO board is flashed with the new source code. So now if I put my hand in front of this object sensor, then the bulb should glow. That is our first case, right? So case number 1, let us put a hand in front of the sensor. You see, whenever I bring my hand into the proximity of this sensor, the light starts glowing. That means what is happening is, whenever I bring my hand, the IR LED which is transmitting, that is getting reflected from the palm of my hand, and that beam is being read by this receiver LED that is sent to the comparator. Comparator will send a active low signal. That active low signal is being read at pin number 2 of the Arduino. Arduino board will turn on the relay at pin number 4, and pin number 4 the relay gets energized, and once the relay gets energized, it will change the state from normally open to the common. So once that normally open to common is done, the circuit which is there, which is the bulb circuit, it becomes closed circuit. So once the closed circuit happens, the bulb starts glowing. So this is how it works. So a presence is detected inside the house, then the light will turn on. When you come out of the room or go out of the house, automatically the lights will turn off. Okay, let's quickly discuss the second case. Let's open the source code. So we have opened the source code. So our second case was, if I use an IR remote, instead of using my hand to turn on and off, let us use an IR remote to turn on the light. So if I press any key on this remote, that should transmit an IR beam from this remote onto the receiver IR LED of the sensor. So moment it receives, the comparator will generate active low, Arduino will send high and to the relay. Relay will become energized magnetically and you have a closed circuit on the light bulb. So that is how the bulb glows. So let us see that demonstration. So to see that demonstration, here we have the source code. I have kept the pin number for IR LED as 2, pin number for relay as 4 as it is. I have taken relay state as Boolean. I have initialized as false. Inside the setup loop, I have given baud rate serial for serial communication, serial.begin at 9600 baud rate. And then I have made a relay pin as output. Digital write, I am initially making relay pin as low. And then I am making IR receiver.begin as IR receive pin. Serial.port login IR relay control ready. So all these function IR receiver.begin and all these has been derived from IR remote.h header file. So before writing this source code, I would ask you to install this IR remote.h by going into tools and manage libraries. If you type IR remote, then you install this IR remote by Sharif, who has uploaded this .h file. So we will be using this .h file for our project purpose. That is how I have called IR remote.h. So now whatever the functions that you are seeing, IR receive.begin, all these are functions derived out of IR remote.h. Now coming to the loop, what we have to do is, once the IR is detected from the remote, I have to detect what command it is that has been detected, what data that has been detected, that I am going to print here, as well as I am going to make the relay pin high. Because I have detected IR data, I'll make the relay pin high. So that is why this logic is given. And parallelly, I will also print the relay state on the serial communication with a delay of 200. So let us immediately delve into it and start seeing the demonstration. So let us flash this directly. All right. Uploading has been done successfully. Now, what I'm going to do is, you see that serial output is relay control ready. So because I have written that in the code, now my serial, all logs will be logged here. Okay. Now I have got the remote here. So what I'm going to do is, I will press a key and that will pass an IR LED, IR data to the receiver. And you will see the light glowing. Let us see that. I am pressing any key here, 1, 2, 3, 4, any of that key. See here. If I press any key or that key, the light will turn off. On, off. So we are demonstrating an IR data being sent from the remote control to the receiver LED, and naturally, and you will see the LED, the bulb getting turned on. So any IR that I send, it is turning on and off. Any IR that any key that I press on the remote, it is turning on and turning off. So friends, we have successfully demonstrated case number 2, that if you send any IR data from the TV remote, it will turn on and of the bulb. Let us move on to our third case, which is the final case. So this is our final case. Now, suppose if I want to my bulb to turn on only for a particular key on the remote, then what should I do? Then we have to modify our source code a little bit. So that is how I have modified here. I have made the receiver pin as 2, relay pin as 4. Everything else is the same here. Relay pin, low, IR receive pin, ready, everything is the same. Only change is in the loop logic. What I have written is, if receiver.decode, if an IR is being received, I will match it with my data first. So here I have taken 71. Why I have taken 71 is because I found that for a menu up button on the TV remote, it is transmitting 71 as the data on the serial monitor. So I saw that in the previous case. So that is why I have taken 71 here, as the data transmitted from the menu up button is seen in the previous case. You can take 0, you can take 1, any number based on the button data that has been transmitted. So I have taken 71 because if I press menu button, 71 is transmitted from the TV remote, and that is being sensed by my IR obstacle sensor module. Okay, so IR receiver.decoded IR data.command, if it is 71, then I'll say received IR code, then I will say serial.print that command, then I will change the state of the relay, I'll turn on the relay pin to high, and then you will see the bulb starts glowing on. And once again I press that same button, menu up button on the remote once again, I'll again receive 71 as the IR data. Then my relay state becomes low, relay turns off. When the relay turns off, my bulb will turn off. So let us quickly see the demonstration here. So here is my remote, here is my IR sensor. So what I have done, if you see, I have flashed this already. I have flashed this Arduino code already now. It has been flashed now. You see that? It has been flashed now. Now, I've got so many keys on this remote. I will press 1, 2, 3, 4. You don't see bulb turning off. I will press pin number 2. You don't see bulb turning off. I will press pin number 3. You don't see bulb turning off. I will press 7, 8, 9. The bulb is not turning off at all. Why? Because I have changed the source code to turn on and off the bulb only for a particular key on the remote. So my particular key on the remote is menu up button. Here you see menu up button. So if I press this button, only then my bulb will turn off. If I press this button again, only then my bulb will turn on. So I will press this, turns off. I will press this once again, turn on. I will press this again, menu up button, turns off. I will press this menu up button once again, turn on. So suppose if I press parallelly any other key, whether it turns off, let us test that. Is it turning off? No. No effect at all, because I have changed the source code in the Arduino. I have made it that if the receiver receives IR data 71, which the 71 data is nothing but of menu up button, only for this button 71 is returned. So if 71 is returned, that is if this key is pressed, only then the bulb will turn on. So we'll see again. Off, on, off, on. Whereas for other keys, it is not happening. So we have successfully finished our case number 3, which was turning on the bulb for a particular key on the remote control. So dear students, as you have seen, our smart automatic lighting system effectively demonstrates how simple components can create intelligent and responsive solutions. So this system highlights potential for significant energy savings, enhanced convenience, and even improved security through automation. This is just a beginning. Suppose you imagine integrating with different light sensors, different IoT platforms, then you can build a truly interconnected smart space. Thank you for your attention and your engagement throughout this demonstration. Stay curious, keep innovating. Thank you, one and all.